I'm Michael Kosakivsky and I've chosen topic 1, which is to provide justification for any scientific theories that explain where memories are stored within the brain. Within this particular presentation, I will attempt to cover three main objectives, which is to firstly outline the progression of memory theories within the last century, then analyse research from both academic theories and unique real-world case studies, and then finally identify and evaluate the strengths and weaknesses of each piece of research. For source 1, I'll be evaluating the multi-store model of memory. This is a widely popular model of memory and it was developed by Atkinson and Schefrin in 1968. As seen from the image on the right, it describes the visual representation of information between three permanent storage systems. These systems being the first, the sensory register, then the short-term memory, and finally long-term memory system. To go into further detail, the flow of information is described through these three main steps, which is number 1, the sensory registry is where information from the senses is firstly stored, but only for a duration of approximately half a second before it is then forgotten. Secondly, then this sensory information moves into the short-term memory system for temporary storage, which will then be encoded visually as an image, acoustically as a sound, or less often semantically through its meaning. Short-term memory is thought to have a capacity of 5 to 9 items and duration of approximately 30 seconds. However, through higher order cognitive strategies, we are able to increase this capacity and duration through strategies like chunking. Lastly, rehearsing information via the rehearsal loop helps to retain information in the short-term memory system and consolidate it into the long-term memory system, which is predominantly encoded semantically within the brain. And now the evaluation of the multi-store model of memory as a piece of evidence. Firstly, its strengths. It is a reliable source and it is referenced across many universities worldwide, including Monash, and it is featured in the prescribed psychology textbook. Although briefly, it does cross-reference previous studies, and specifically studies detailing cases of patients with brain trauma. Furthermore, using those cases to apply to the sensory model and specifically how this trauma affects functions within the sensory model. It is also hailed as a gateway within psychology for being a path for further research and remodeling by present-day psychologists and cognitive scientists. And now onto the weaknesses. The multi-store model of memory by Atkinson and Schefrin does not detail any experiments conducted by them. Instead, it is rather just solely based on academic theory rather than practical study. Furthermore, the model is considered oversimplified as evidence suggests that there are multiple short and long-term memory stores, as primarily speaking the long-term memory system can be split into episodic, procedural and semantic memory. Moreover, the short-term and long-term memory are not to be viewed as separate entities or systems in which the model on the previous slide visually makes them out to be. Rather, they are interconnected and serve each other through retrieval and overall function of memory. In source 2, I will evaluate the case study of patient HM. This unique case study will further our understanding on the structure and function of the hippocampus in memory. The case study here follows this simple timeline. In 1953, Scoville performed surgery on the 27-year-old HM to cure him of epileptic seizures. The surgery involved what was called a partial medial temporal lobe resection, where Scoville removed 8 centimeters of brain tissue from the anterior two-thirds of HM's hippocampus. As a result, HM was soon after diagnosed with anterograde amnesia and subject to further cognitive study by Milner within an academic journal has spanned over 50 years. As a result of the practical removal of HM's hippocampus, he now displayed an ability to complete tasks that required short-term memory and procedural memory, but an inability to do so in tasks requiring long-term episodic memory. Similarly, he displayed the ability to recall long-term memories that existed well before his surgery, but an inability to create new long-term memories. Overall, this suggests that encoding and retrieval of long-term memory information is mediated by distinct systems within the brain. To go into further detail and in practice, Milner documented that he could perform complex motor tasks and even comment that it seemed easier than he expected, although this was without realizing, due to his interrogate amnesia, that he had done that particular task countless of times before. And this task is the pointed star task, which had HM draw a star in the reflection of a mirror. And over 3 days of drawing the star, he continuously got better due to having less errors, as seen in the top right. So this suggests there's some sort of still functioning memory system within HM, and it is not the hippocampus, which has been surgically removed. So now this suggests that particularly procedural memory and associated motor functioning and tasks associated with procedural memory is not taken place or associated with the hippocampus, but instead some other structure. He also lost his memory for events that happened after his surgery. He was unable to remember moving house and even that he had eaten a meal 30 minutes prior. He had also suffered some retrograde amnesia of recent events preceding the surgery, which suggests that hippocampus is involved in some sort of consolidation of recent information. However, his early childhood memories remained intact. His intelligence also remained as before, above average, which suggests already existing theories that intelligence and high order thinking is primarily located within the cortex. And on to the evaluation of HM as a point of research. Its strengths. HM suffered from pure or clean amnesia, which means there was little to no other symptoms that could have added as a different variable and further complicate research. Milner used already established memory tests and puzzles, which had been designed by other cognitive psychologists and are still used to this day in other psychological and cognitive experiments. And further research of HM was conducted by a qualified team at MIT. And weaknesses, case studies like these are particularly unique and they're not generalizable to a wider population and they cannot be recreated. So HM was a one-off case. Scoville and present-day surgeons could never perform this surgery again. And by that regard, if the results are not able to be replicated, then it can be defined as unreliable or invalid. No memory tests were conducted on HM before the surgery, so there is no control set of data by which Milner can compare her now newly gathered set of data and accurately and reliably describe the differences as a result of the hippocampus removal. And finally, the evidence was arguably gathered unethically. Critics state that HM was in no position to withhold his consent and was used as a sort of human guinea pig within this experiment. And finally, source 3, which is research done by Lashley. Lashley began his exploration of memory close to a century ago. His objective was to find the memory's exact location, searching for evidence of a theorized engram, which is a group of neurons serving as a supposed physical representation of memory. Lashley trained multiple rats to navigate a maze. After the rats had successfully completed the maze, he would then subject them to lesioning in the cerebral cortex via a soldering iron. He intended to move the engram and thus erase the memory of the maze from the rat and its ability to navigate it. However, the rats were still able to successfully complete the maze, and so it can be concluded that memory is not localized to a supposed engram, but is instead distributed across multiple parts of the brain, this principle being mass action. He also suggested another principle called equipotentiality, which describes how one area of the brain involved in memory is damaged, another part of the brain can take over and serve that memory function. The strengths of this research: Lashley's hypothesis was not supported, so his results were not what he expected, which can negate any potential confirmation bias. The rat maze method is still widely used and accepted in memory cognitive psychology experiments, so it is valid. Weaknesses: it has weak generalizability. The brain structure and function of rats cannot be translated to the brain structure and function of humans. Use of a soldering iron is outdated and it isn't accurate. Conclusions on mass action and equipotentiality were quickly drawn without any further research. In conclusion, the structural function of memory is underestimated in its complexity. Many studies and theories tend to be linear and two-dimensional. Such research in combination, however, proves valuable in suggesting that memory and its variety of different types are stored within different parts of the brain. Now a base level understanding has been established and further research is required. Thanks for listening, and here's a list of the references used within this presentation.